Welcome back, everybody. We are here, TCA's free pathway to sustainability webinar series, which is intended to keep the TCA members informed while introducing a conduit for communication and collaboration as we move towards net zero. Our first session this past May was an overwhelming success, with more than 100 participants hanging around to the end. As presented last spring, the City of Toronto has identified aggressive building sector goals, leaving the GTA construction industry with the monumental task of determining how these goals can be met. Today, our panelists will be exploring net zero infrastructure and what the Greater Toronto Area construction industry is doing to support not only the aggressive targets established locally, but also worldwide. Future sessions we're looking at will be addressing net zero, the passive house, and net zero, the low-hanging fruit beyond. With only an hour available to cover a vast extent of information, our panelists will try their best to address questions added to the Q&A box at the end of the session, with any unanswered questions addressed following the webinar. Today, I'm honored to introduce our esteemed panelists who are on the forefront of the movement towards net zero in their respective industries. We have representing the legal industry from McMillan, Kailey Sutton, the design industry, Lyle from Footprint, the steel industry, Behzad Karimi from Burnco, and from the cement industry, we have Sandra Petrevan. As today's discussion will focus on embodied carbons rather than operational carbons. As we move towards the very ambitious net zero goal, our understanding of the issues faced by the construction industry at large continues to expand. Today's panelists will start by each providing a brief snapshot of their role in the movement towards reduced embodied emissions. We know that things need to change, but we still aren't quite sure what all these things are. It's our hope that by the end of today's presentation, you'll have a better understanding of some of the key players in the industry, their views of the changes underway, and maybe even get some insight into the effective change mechanisms, which may not necessarily result in additional project costs if managed effectively from the outset. Our first session, we'll have our first speaker is Kailey Sutton from McMillan. She's practicing in infrastructure, municipal, and land use planning law, advising on the development of projects, bylaw, and regulatory compliance issues and building code matters. Also, she's obtaining front-end approvals and permitting as well as drafting and negotiating complex agreements. Kailey, you're on.
Thank you, Sandra, and hi to everybody. It's a pleasure to be here and speaking on this topic today. So I understand that I've been asked to address net zero emissions on an infrastructure basis from a legal perspective. So as you can imagine, and if you have familiarity with the regulatory regimes at all, you might believe that I didn't quite know where to start on this topic. It's a big conversation, and we have multiple levels of government and so on. So I'm going to, anticipating that I have 10 minutes to cover this, take a very high level approach. And my goal is that at the end of my session today, to give you a sense of what's out there in terms of the regulatory regimes in Canada, Ontario, and then more locally, and where you might fall into it so that you know at least where to start looking and what questions to ask. I wanted to start, though, by setting some stage with the key facts. These points are brought to you by Canada's Net Zero Advisory Body. Note that this is from a report that was put out over 2 years ago, so the facts may be slightly different now, but I think the message is the same. So human activities have already caused a 1.2 degree change of global warming above pre-industrial levels. Canada is warming at twice the rate of the global average. And this might lead to increased displacement and migration, greater geopolitical instability, damage to critical infrastructure, and disruption to supply chains, air pollution, extreme heat, and vector-borne diseases. So 2 years ago, yeah, I think we're seeing those supply chain issues, vector-borne diseases, air pollution, extreme heat, all of these things are happening and they're impacting everything, but also including the infrastructure, construction industry. So next slide, please. Thank you. More facts. Canada-based. Canada's overall emissions growth over 1990 to 2021 period was driven by increased emissions from oil and gas, as well as transport sectors. The decrease that was experienced in some of this was due to electricity and high industry sectors. So either better electrification or change in those industry sectors. And Canada's homes and buildings account for 13% of national GHG emissions. So we have something to do with this. But okay, we've identified some foundational issues. And one of the other early issues I think a lot of us are experiencing right now is that there's inconsistency with definitions when we're talking about greenhouse gases, net zero, and so on. And there's inconsistency with respect to formulas. Are we talking targets? Are we talking legislation? So I thought I would put up a few definitions just to get us on the same page for this discussion. So net zero emissions is the anthropogenic, meaning human generated, emissions of greenhouse gases into the atmosphere, where they're being balanced by anthropogenic removals of greenhouse gases from the atmosphere over a specific period. So we're at a net of zero. And greenhouse gases, you know what? I noticed that there's different definitions of what that can include too. So, you know, these are typically the greenhouse gases I understand that people are referring to, carbon dioxide, methane, nitrous oxide, and so on. So net zero doesn't mean no emissions. It means we're balancing them out. And so unsurprisingly, there's inconsistency among definitions and formulas. But Sandra, if we can go to the next slide, please. All right, so we have these high level issues. But as I mentioned, this is a big conversation and where to start with the regulatory regime. It's a multi-dimensional question. And of course, as the lawyer, I'm saying, well, it depends. And what does it depend on? Well, a number of factors. So which regime applies to you? What are the rules? Well, it depends. What level of government are we talking about? Are we talking federal, municipal, provincial? What's the geographic region that you're located in? Because as we'll discuss later on, depending on what province you're in, depending on what the nature of your project is, it can change by your region. What type of infrastructure are we talking about? Infrastructure is not just one type of construction. We have transit, we have buildings, we have utilities. The stage and process. So are we considering how to construct? Are we deconstructing something? Are we talking about operating and maintaining? The level of formality. So are we thinking, okay, it's an industry objective, or are we talking this is a piece of legislation that I will be non-compliant with if I don't do these things? Also, what parties are involved? Is this a procurement between a government body and a private party, or is this simply between two private parties? So it is a big question and a big conversation, and I can't get through all of it today, but I will try and touch on some of these so you have an idea. Next slide, please, Sandra. So for example, depending on the stage of the process, as I mentioned, and Sandra touched on this a bit when we were starting, embodied carbon would be carbon emissions associated with materials and construction processes throughout the whole life cycle of that building or infrastructure. Whereas operational carbon is the emissions associated with energy used to operate the building or in the operation of infrastructure. And then end of life carbon, these are the emissions associated with deconstruction, demolition, transport from site, waste processing, disposal phases, and so on. And these are only some of the types of sources of carbon. Thinking of others, what type of transit or transportation are you using to get your goods? Are we shipping? Are we using rail? Are we using a vehicle-based? So it depends on what we're using to get you to your site. A lot of factors coming in here. Next slide, Sandra, please. So if we go on, depending on the level of government or the parties involved in the nature of the project, trying to help you visualize here that we have, you know, these very clear 3 levels of government, and then we have public and private. That's how I'm trying to at least frame this today. So perhaps most of all, in respect of the rules, the nature of the project and the parties will matter. And this will tell us what level of government has jurisdiction and which regime applies. For example, like I said, if we're talking about procurement between two private parties, the rules will be different than if it's between a government body and a private party. So let's look at this from the federal perspective first. Sandra, slides, please. So let's go high level again. As you are all probably aware, Canada is a signatory to the Paris Agreement. It's an international treaty on climate change. And it was adopted by 196 parties at the UN Climate Change Conference in 2015. Okay. And then Canada went one step further with a number of other countries and made a commitment for a certain amount of reductions to net zero emissions by 2050. The federal government has therefore legislated it's enacted certain legislation as of 2021 to this end. But note that legislation, being the Canadian Net Zero Emissions Accountability Act, it really only puts in place requirements for the ministers, so for the government itself to comply with, largely being monitoring and reporting. So they've put in place a reduction plan because the act says they have to, and it outlines a sector by sector path for Canada to reach its emissions reduction target of 40% below 2005 levels by 2030 and net zero by 2050. But arguably, this probably doesn't really apply to most people in our audience today because this plan is, again, for the government to take actions. So unless you're entering into a procurement contract with the federal government, then you'll be subject to, for example, if you are entering into that procurement agreement with the federal government, you will be subject to the policy on green procurement that was in place in 2006. But then most specifically and more recently, the federal government has also brought out standards relating to embodied carbon in construction and standard in the disclosure of greenhouse gas emissions, the setting of reduction targets. So these two new standards have come from it. Again, though, that's a pretty small number of people that might apply to in terms of what relationship we're talking about. Next slide, please, Sandra. So just showing this is their nice visualization of this 2030 emissions reduction plan, and it sets it out by sector. But as I mentioned, a number of things in this plan are largely just putting in place funding because this is trying to instigate change as opposed to mandate it. And so, for example, like the Canada Greener Homes Loan Program, additional investment, expanding low carbon economy fund, additional funding for zero emission vehicles, and working with provinces and utilities to establish a pan-Canadian grid council. So it's all part of the government's plan. Good. So next slide, please. Some of you may know, however, legislative powers in Canada are divided between federal and provincial, where the federal is generally in charge of environmental matters. The province is generally in charge of civil and land use matters, including construction and design. So most of these policies and regulations are going to come in here as impacting most people, I imagine, on this call. And so the feds have, however, brought in a net zero energy ready model that was brought in 2018 by the government, well, proposed in 2018. It's evolved since, and it's become part of this National Energy Code of Canada for buildings. So this was developed as part of a commitment for improving energy efficiency of Canadian buildings, and it applies to large buildings and sets out technical requirements. But as I mentioned, this is the province's purview. So the federal government has had a goal of having the provinces adopt this. The provinces largely, in some way or another, have adopted some or all of this building code, and they've entered into a harmonization agreement so that between provinces, we're starting to have similar requirements. Ontario's adoption of the NECB is through amendments to our Ontario Building Code. And so if you are building in Ontario, you're going to be subject to the Ontario Building Code, subject to a few exceptions. And so the building code contains requirements for how energy efficient a building must be, like required thickness of insulation, maximum number and size of windows, and so on. You're probably familiar with that, but maybe didn't know where that came from. Other sources that you might find some of this net zero policy working its way in is through planning mechanisms like the provincial policy statement. So the PPS 2020 requires planning authorities to support energy conservation and efficiency, etc. Note, though, and as many of you may be aware, there's a new proposed provincial planning statement replacing the PPS and the growth plan. And this new PPS, if passed as drafted, actually requires the government to go a little bit further and to plan to reduce greenhouse gas emissions. Sorry, the planning authorities, not the government, but in any event, it's going a little bit further. And so these are some of the mechanisms we have provincially in place. Sandra, next slide, please. The province, however, delegates a number of its building code matters to municipalities. And so you'll likely run into a lot of this at the municipal stage. So you'll likely be aware that if you're in building, that you're required to meet a number of items that are considered applicable law under the Building Code Act to obtain building permits. One of those is, for example, a site plan approval. And site plan approval doesn't apply to all jurisdictions in Ontario, but where it does apply, you'll be subject to approval conditions that need to be met. Those approval conditions generally align, well, and any planning approvals need to align with the planning instruments above it, including zoning bylaw, official plan, and PPS. And so this is how the province's mandates start to come down into what the municipality is regulating. In addition, municipalities have been putting in place their own standards. So there's the Toronto Green Standard, for example, that many might be aware of. It's currently on version 4. And as they've said on their own website, that it is a critical tool in implementing their official plan policies. Mississauga, for example, has the Green Development Standards, which is currently being updated, and I know it is open for industry consultation. And Ottawa, for example, has the High Performance Development Standards, and it notes on its website that it's a collection of voluntary and required standards that raise the performance. Okay, so they're standards, but they're being raised to being policies that then come into site plan conditions that then become implemented as a condition of approval as compliance with applicable law for you to get your building permits. So this is how Ontario's starting to work these net zero emission policies in through the regulatory framework. I do note, like the federal government, the province, and many municipalities also have their own procurement policies. So if you're entering into an agreement with the municipality, then you'll likely be subject to additional standards and policies. But again, that's something that they as owner are enforcing, not because it's necessarily law. Next slide, please, Sandra. So my last slide, but I wanted to highlight some of these challenges as I think you maybe can have pulled out yourselves through what I was saying. What I started with, there's inconsistent definitions, targets, standards, means of measurement, and so on. And so the industry, I think, is trying to come together to align, because without consistency and even our starting definitions, how do we know how and when we get to these end targets? Many of the requirements apply to public procurement only as actual legal requirements. And so, and even then, not necessarily law. And so what are we doing that is in place that can actually enforce some of these requirements? Many are limited in scope. So the standard of embodied carbon in construction currently only covers ready mix concrete. So we need to figure out ways to expand this and make it apply more broadly. And most include reporting requirements, but not penalties for missing a target. So for example, the Canadian Net Zero Emissions Accountability Act, it even says that the instruments included in that act are actually not statutory instruments. So again, they're more like guidelines. So not to end on some note of concern, but more so to say, at the moment, we've got a lot going on in terms of regulatory regime. I think the industry needs and is doing a really good job of trying to learn more about it. And we've got some struggle, like some challenges to overcome. And thank you to the TCA for hosting this session to try to help us overcome some of these challenges. So I will end on this note and look forward to hearing my co-panelists speak about the technical parts related to this industry. And please reach out to me if you have any lingering questions or would like to discuss what might be applicable to your project.
Thank you, Kailey. Definitely a lot to take in here. And most importantly now, we know who to contact when we start digging into all these regulatory requirements. Our next speaker is going to talk about what's happening in the design industry. Lyle Scott is a principal at Footprint. He has over 25 years experience in sustainable design, development, and operations. He's a trained mechanical engineer specializing in energy efficiency and is known for collaborating with architects, engineers, and developers to create the most appropriate sustainability solution. Lyle, what can you tell us about the embodied carbon and how designers are moving towards the reduction of these emissions?
Well, one of the interesting places to start is that I'd say that there isn't many in the industry who really understand what embodied carbon is. It's a term that's new to most of us, and due to the regulatory changes that we're seeing, I feel that a lot of us are going to need to become experts in it quickly. Good way to think of it, I sort of have a circle here up on the screen, and we often think of embodied carbon as the hidden environmental impacts. A piece of material shows up on the construction site. Maybe it's a piece of cladding, window system. Where did it come from? Well, there was mining involved to get the raw materials out that had embodied emissions. There was processing in a factory to turn that raw material into something useful like glass or metal. That glass and metal was manufactured into the window system that showed up on your site. It was shipped to your site. We're using it in our building, and at the end of life, we're going to have to dispose of it. Each stage along the way has some embodied emissions. We're using equipment that is, burning natural gas or burning diesel fuel or whatever other fuels that are having an impact on our planet. So on to the next slide, you'll see an interesting little pie chart. And, I've been involved in this industry for literally decades, and we've always focused on what happens with the operations, our gas bill, our electricity bill, and we've focused on reducing the energy associated with operations of the building, our heating and cooling and lighting, etc. And we kind of haven't even thought about the energy that's involved in building materials and construction. There are different sort of stats, but when we actually take a look at it, it's a big deal. And up until this point, all of our efforts have really been focused on making our buildings more energy efficient without looking at the impact on the materials that we're selecting to go into our building. So on to the next slide. As we make our buildings more and more and more efficient, it's actually projected that the embodied carbon impacts of a construction project will basically be equal to the operational impact of that building over the 60-year life of that building. So what do? On to the next slide, we'll do something which we call a life cycle assessment. And a life cycle assessment quantifies the embodied carbon of a particular design, predicts what that embodied carbon is going to be over the life of the building. And it's looking at the different stages, the product stage, the construction phase, the use stage, and the end of life stage. And this is something that we could do particularly it's most useful, I think, at the early design stages when you have a lot of different design options on the table, when you're considering different materials, different potentially massing or other options that you may have at the earlier stages. As you get further into the design, you could start to refine some of your design decisions, and this life cycle assessment will get a little more accurate. On to the next slide. Life cycle assessments have only been really commonly discussed in our industry since LEED version 4 came out. That was a handful of years ago. And it's been, I'd say, niche. There's been a limited level of knowledge. That level of knowledge has increased with the release of the Canada Green Building Council Zero Carbon Building Standard. Both of these standards are voluntary. So it really is up to those who want to be known as being an industry leader in sustainability to latch on to, one of these standards is most common. There's other standards out there, but these are voluntary options. On to the next slide. Kailey mentioned that the Toronto Green Standard is looking at embodied carbon, and they came out with some research. This research here was done by the Toronto Atmospheric Fund, and it's a study that was done with the University of Toronto. They analyzed a bunch of buildings, and you'll see here on the left, we have Part 9 residential buildings, single-family homes. We have large residential buildings in the next column, and then commercial buildings and other building types in the last column. Really what it's showing is how the best building performed, and a lower number here is best, a higher number is more embodied carbon. And really it's showing how the best buildings performed and how the worst buildings performed. And what you could see, there's the average is the little square in the middle. So for the average embodied carbon was 191 for a residential building, a small single-family home, and 435 for a large multi-residential building. That's kilograms of CO2 equivalent emissions per square meter. On to the next slide. Earlier this year, City Council approved a change to the Toronto Green Standard. It changed the Tier 2 and above embodied carbon requirements. So the Toronto Green Standard Tier 1 is mandatory. Tier 2 and Tier 3 are not mandatory. They are voluntary. So the city did not make any changes at this point in time that impact mandatory requirements. They impacted voluntary requirements. They set a target of 250 kilograms of equivalent CO2 per square meter for a single family home. Now that is about 24% worse. That's more emissions than the average in that University of Toronto study. They set a target of 350 for high-rise multi-residential and non-residential. That's 24% better than the average in that U of T study. They set a Tier 3 requirement for mid-rise and high-rise residential of 250. That's 74% better than the average building in that U of T study. Thankfully, they said that their own facilities must have an embodied carbon target of 350. And we're working on quite a few city buildings, and I could tell you that is going to be very difficult for them. Community centers are very intense buildings from an embodied carbon perspective. And we're seeing numbers of over 400. So they have a lot of work to do. They're going to have to learn lessons. On to the next slide. These are all voluntary requirements, right? They're Tier 2 and Tier 3. So why does it matter? Well, the Toronto Green Standard has one of the things that they did, it came out in 2017 where there was a real change to version 3. And what they did back in 2017 is they said, here's what's going to happen for the next versions of the Toronto Green Standard. We're telling you that the Tier 2 is going to become Tier 1 in the next version. And they've given us the dates for this. So our current version is version 4. It's been in place since 2022. There's going to be a new version in 2025 and a new version in 2028. It is anticipated that the version 4 Tier 2 voluntary requirements that are in place right now will become mandatory in 2025. And similarly, the Tier 3 version 4 current requirements will become mandatory in 2028. That's my speculation, but it's been backed up by a statement that came out in that same city council ruling that happened on May 10th of 2023 of this year. City council directed the chief planner to report in Q2 of 2024 on the feasibility of mandatory embodied emission caps for new development as part of the update to the Toronto Green Standard to version 5. So what I'm saying is that is kind of notice that effective June 1st, 2025, we can anticipate mandatory targets in the city of Toronto. It's not ruled on yet, but that's sort of the guidance that we're getting. On to the next slide. You're going to see the same thing happening in many, many municipalities. This, for an example, is the draft Mississauga Green Development Standards. The targets are very similar. Again, they have Tier 2, Tier 3. Their years are slightly different. They're suggesting here that Tier 2, they're going to have a mandatory target in 2027. They're going to increase it again in 2030. We also understand that that National Energy Code for Buildings is going to have a 2025 date for embodied carbon. Again, it's a national energy code, so it'll only become relevant when it's adopted by the provinces into the Ontario Building Code and other provincial codes. On to the next slide. Lots we could do. Most important thing is, as an industry, we have to start educating ourselves now. We can't wait. We really cannot wait. There are a lot of things, and not all of them increase cost. One of the big things that I've seen is a reduction of below grade structure, which can significantly reduce costs. Obvious impacts on parking and other things like that. There are material substitutions that we can make, but most importantly, I think innovation will be necessary, and you will need to start working with your suppliers and talking to them about embodied carbon. Next slide, big way to close. So many of us are still thinking like, you know, oh, we're going to do what we did last year or the year before that, just updating it. We really, really, really have to take a different approach. I have not seen the industry change at such a rapid pace at any point in my career as what's happening now. Sandra, back to you.
Thank you, Lyle. That was fabulous. What we're leading into, I think, is the most important thing, is that making people aware. We've got to know what's coming, and we need to know what everybody's doing out there and how we can fit into it or take advantage of all the learning that's taking place. Now next we have Behzad Karimi, who is a structural engineer with Burnco Manufacturing. He's got 25 years experience in the steel industry. He has his master's degree in structures and is a structural engineer and project manager with Burnco Manufacturing. Recognizing that the steel and cement count for 14% of global CO2 emissions, and 47% of the construction industry's emissions, steel manufacturers and installers have the largest opportunity for improvement. Can you tell us how Burnco is moving forward towards the reduction of carbon emissions?
Sure. As you know, the Government of Canada has implemented a standard on embodied carbon in construction, currently, steel construction product is not included in that standard. A steel product that should be considered as mill products or final product used in construction. Steel manufacturing produces more CO2 than any other heavy industries, comprising around of total global emission, 8% total global emission. Efforts are in place to move steel production away from coal-fired furnaces to the ones powered by electricity or hydrogen. The steel supply chain has potential to reduce emission by replacing fossil fuels with low or no carbon option, switching to renewable electricity and electrifying the vehicle fleets, and increasing the usage of recycled material. When I'm talking about fleet, imagine we have a project like 5,000 tons of steel. Like imagine transportation for this steel from mill and then final product. How much fuel it has to be consumed for this only project. We have a couple of these projects in our facility, and you know, steel industry is a big industry in Canada and US, and you can imagine how they scale up the steel. The steel in North America, there has been a great switch to recycled steel as a feedstock for mills, but globally, coal-fired production is still the predominant method of steel production. The challenge for North American producers is that they are competing in the world market with the steel as a commodity. To utilize methods that are more expensive will put them at a competitive disadvantage. This has somewhat been addressed by government with tariffs. This is a big issue for fabricators like us, which we want to compete with the other fabricator and with the steel coming from overseas, which is cheaper, and using the furnaces with the fuel. Next slide, please. So, how steel manufacturing are currently expanding and planning to the future? So there are a couple of aspects. One of the major ones is design. Many sophisticated 3D design softwares have been developed which assist to optimize the structural design, leading to have less steel than previous software or manual design methods. Less steel, less CO2 emission. Welding fumes are one of the origins of CO2 in the steel industry. Optimizing the joint design to use less welding size or to use the minimum possible welding joint is one of the solutions to reduce emissions of CO2. This is something we implemented in our plant here. Steel is a recyclable material, so there is the ability to reuse the material multiple times. This is one of the big advantages of the steel if we can think about reusing steel in our future project. Next slide, please. So, use low carbon steel. These days, the use of low carbon steels has been increased comparing to the past. That's a good news for the steel industry and also for industry to reduce CO2 from steel. Purchase the steel from local mills like USA or Canada, because you know, as I explained, the transportation for the steel is a big item contribute in the CO2 emissions. So if we reduce the transportation, we reduce carbon is transferring everywhere. Burnco and its parent company have been developing the robotic welding machines to be replaced with the traditional welding machine as well as automated plasma cutting, which reduces production time and waste in the welding process. concentrate on local projects to avoid line transportation of steel finished products to the site. So currently we're focusing to have more local projects in Ontario rather than having some project in Alberta or east of Canada. Shipment from steel mills to shops are often done by ship or rail, most effective method of transportation. This is something we insist when we talk to our suppliers. Next slide, please. In our fabrication process, we're utilizing the modern nesting software, which minimizes the scrap weight of the steel in project. In our production, we utilize mill steel at mill length, and we optimize the modern nesting software to maximize the yield and minimize the scrap. So when we have a project, we try to have the steel in a size which has the less scrap. So having said that, previously we had about 5 to 6% scrap on the steel. Right now, with using those software and all these measures, we try to reach to 1% scrap on the steel. Equipment optimization and convert the fabrication tool from fuel to electrical sources is one of the measures we're doing in our plants. Next slide, please. So what are the biggest hurdles faced by the steel industry? That's an important question. Producing green steel is an expensive process, and the industry needs to scale up rapidly to hit net zero targets. Today, 75% of the steel worldwide is still largely made in coal-fired blast furnaces. North American and European mills are generally converting to scrap and electrical furnaces at a high cost. At the mill level, now technologies are expensive and can be cost prohibitive, and will make mills less competitive than the mills from the other jurisdiction. It's a difficult balance for the mills to scale up to hit net zero targets while remaining competitive in the market. At the manufacturing or fabrication level, we are in a competitive bid. To be successful, we must source the cheapest available steel. On larger projects, fortunately, there are North American provisions to give local mills that advantage. More of this is needed in government level or provincial level. There have been successful trade actions against dumping for jurisdictions such as China and other countries for mill steel and fabricated steel. We need more of these actions. Next slide, please. What help we need? Steel has a large role to play in lowering the future emissions because of its ability to be recycled, and it is sustainable in the long run. The steel in long term can be remediated, can be reinforced, and recoated to have a very long lifespan. So we should have more steel in the design of the building. I'm talking about building with a steel design. Life expectancy and sustainability of steel comparing to the other material in the infrastructure system need to be considered. The steel manufacturer can achieve carbon neutrality if governments implement the right policies in the next 5 years. According to International Energy Agency, in a new report, the IEA says the economies need to recognize the use of interim technologies that substantially reduce emissions if they aren't considered zero emissions. We don't need to, because it's not mandatory now, we don't need to say zero emissions. We have to have a plan, short plan, interim plan, to reduce it substantially. At the government level, more financial aid or incentive programs are necessary to upgrade the technology. And the last item is tariffs on dirty steel, blast furnaces versus electric arc production. Sandra, back to you.
Thank you. It's wonderful to see that you guys are advancing in your understanding and your movement towards what we can do in this industry. Now, we'd also have a speaker here for the cement industry. Sarah Petrevan is the Vice President of Sustainability for the Cement Association of Canada. She's the 2018 Clean 50 Emerging Leader Award recipient. With her expertise in the industrial decarbonization, she advocates for policy change. She's testified before legislative committees and provides regular commentary for media. She also provides advice on topics such as carbon accounting, procurement, and the scale-up of clean technology. Sarah, what can you tell us about how your industry is moving towards the reduction of carbon emissions?
Sure. Thanks, Sandra. So I really like how Kyle sort of set up the conversation on embodied carbon in construction. But I think we have to think about concrete, what happens to it before it gets to a construction site? What's its carbon footprint and how do we lower it? And so this was something that the Cement Association of Canada grappled with many of our allies in the concrete industry. And so, Sandra, if you just switch slides, last May we created this this action plan to net zero. So Canada's cement industry is pretty vast. We have 15 cement plants across the country with more than 1,000 associated facilities, manufacturing everything from precast concrete products, ready mix, concrete pipe, concrete masonry, etc. Next slide. And so we developed ourselves our action plan to net zero. And what it does is this outlines the steps that Canada's cement and concrete sector will take to achieve our net zero carbon goals. And it featured contributions from members of the cement and concrete industry across the country. And we also had the report in our plan peer-reviewed by other allies in the industry, academics from environmental, non-governmental organizations, just to test some of our assumptions and the data that we provided. And we received a lot of feedback on the report, namely that this is one of the most transparent reports ever produced by a heavy industry association in Canada. Next slide. And maybe just to say, like, a comment on the benchmarking data related to the federal government's embodied carbon in construction. So the reason why ready-mix concrete is the only material covered is because, as far as I know, we're the only industry that has actually provided benchmarking data. Because, of course, what is lower carbon concrete? Lower carbon compared to what? And so it's always really important in regulatory approaches or in standards, in anything, that you have a baseline so that you know what lower actually means. So let me talk a little bit about our targets. So we modeled two different types of targets. So we did against a baseline of 2020 emissions. In keeping with the Global Cement and Concrete Association's Concrete Future Net Zero report, we mirrored their 2020 baseline. But we also looked at a business as usual scenario in which we planned for like a modest increase in the use of concrete. Because obviously, like, we have to plan for market conditions, and it's not actually achieving net zero if you don't take market conditions into account. Maybe one other quick point around our net zero action plan is that we really tried to get to true net zero, which means that we didn't account for purchasing of offsets, nor did we account for avoided emissions in our plan. So this is like what we call like a true net zero action plan. Next slide. And so, for us in the cement and concrete industry, right, there is no silver bullet. There's not going to be one magic solution that's just going to wipe out all of our emissions. It's going to take a lot of different things. And this action plan specifically focuses on existing, proven, commercially available technologies today, at present. It's not to say that we don't need help. We absolutely need help. But we envisioned, like, okay, if nothing changes and, you know, there isn't some white horse bringing in like a new clinker chemistry that's, you know, totally available at scale tomorrow, how are we actually going to do this? And so we looked across the value chain of our product. So everything from clinker on down to concrete and beyond. So really like across the life cycle, and said, okay, where are these emissions reductions going to come from? Next slide. And so we looked at what we call the 5 C's. Next. Which is clinker, cement, concrete, construction, carbon uptake. And then I always like to talk about this kind of sleeper 6th C, which is carbon capture, utilization, and storage. Next slide. So clinker, for those of you that may not know, this is the most GHG intensive component of cement, but it is the key ingredient that gives cement its binding properties. And so it is the kilning process. So it's not only the GHG emissions from you know, like the fuel source combustion, but also there are process emissions as a result of a chemical reaction. So like we call these emissions the chemical fact of life. And so our main emissions reductions in this area are about replacing fossil fuels that we use in the kilning process, substituting clinker, which means that we over time are able to lower the ratio of clinker used in cement through the use of something called supplementary cementitious materials. And then, of course, the deploying of carbon capture along with either utilization or storage, depending on the jurisdiction that you're in. Also, you know, we acknowledge that thermal efficiency, decarbonated raw materials, and novel clinker chemistries are going to play a role in this in the future. We're just not sure what those are. Next. Then we go and we look at cement. So obviously the most energy intensive phase of the concrete value chain is at the cement plant. And so, you know, our main drivers of emissions reductions are really at looking at new and different cement blends. So I talked about, you know, the increased use of supplementary cementitious materials, you know, the shift, the 100% shift to Portland limestone cement. Many of our members across the country have plants that don't produce anything but, and then of course the increasing emergence of blended cements. Next slide. Concrete. So concrete is the most second used material in the world after water. We like to say that a net zero future will both literally and figuratively rest on concrete because of its ubiquitous nature. And it's also an incredibly climate resilient material and can support, you know, in infrastructure, for example, a reduction in operational carbon, right, due to its heat retention or cooling properties, depending on how it's used. And so really, you know, our emissions reductions on the concrete side is going to look at optimizing the concrete mix for the application. So admixtures, also perhaps the incorporation of recycled concrete aggregate where allowed. But also, you know, some things that Lyle mentioned, right? Optimized concrete design to ensure not over specifying strength and durability requirements. And then, of course, powering how we produce concrete with clean energy. So it's clean electricity at a ready mix facility, and also, you know, a shift over time to zero emission vehicles. So, you know, maybe one day you will see a concrete mixer rolling down the street that's powered maybe by hydrogen or electricity or something else. Some people call them cement mixers. They're not cement mixers, they're concrete mixers. Next slide. everybody on this call knows this, but like I have my daughter has these books and she's like, it's a cement mixer. I'm like, no, child. Okay, so construction. So, as Lyle kind of suggested, right, there are big opportunities to reduce emissions through design and construction. And this is obviously outside of direct control of our industry. And so it requires partnership as well as continued education and awareness and working directly with the construction industry, which is why I'm so glad you guys asked me to present today. So, in this C, our main drivers of emissions reductions looks at material efficiency. So, column spacing, voided slabs, etc. And then also waste reduction. Don't order more concrete than you need for a job. Oftentimes, like, I think I saw a stat once that concrete makes up, can make up, 70% of a job site and maybe makes up like 3% of the budget. So just because it's less expensive, maybe you don't order more than you need. Next slide. Finally, there's this thing. Concrete has this secret power. And I'm not a chemist, but it is the result. So basically, when you're creating clinker in the kiln, when you process the limestone, you get calcium oxide and CO2. And basically the way to think of it is that once the cement is in concrete, at some point the calcium oxide wants its CO2 back. And so there is a natural property that concrete can sequester CO2 from the atmosphere and permanently capture and store it within the concrete. Now, how much of this actually happens and on each project varies, right? So this, we did our numbers based on the most prevalent research study, which is out of Sweden, but there are a number of Canadian studies happening with infrastructure that look at drill core sampling to actually test and see how much carbon uptake we're getting in different infrastructure applications and different weather, etc. But just to say that, like, our ability to kind of park emissions against carbon uptake is going to decrease towards 2050 because our process emissions are going to decrease. And so there's not going to be as much calcium oxide that wants its CO2 back. Is basically just a quick way of, a very elementary way of explaining it. Next slide. And finally, I want to talk about CCUS because it can be a controversial topic. But I want to make it clear that it is vital to the cement and concrete's ability to reach net zero. We cannot reach net zero without it. Why? Because we have process emissions. And so deploying CCS technology at full scale during the manufacturing can eliminate all of our process emissions and maybe any small amounts of remaining combustion emissions, because obviously our goal is to go to as close to 100% clean fuel source as we can. And just to say that today there is no other technology or process that can entirely eliminate process emissions. The cement industry in Canada is working on taking a leadership position. You may have heard that a couple of our members are looking at building carbon capture plants in Alberta. One of them in Edmonton that is being conceived right now, and all this information is the public domain. But if we are successful in building it, we'll be the world's first net zero cement without the use of offsets. And it will be the world's first full-scale carbon capture deployment at a cement plant. So we're pretty excited and very hopeful that that actually does come to fruition. Next slide. I want to talk a little bit, just very briefly, about kind of what we call enabling measures, right? These are things that we need to happen in the world, with government, in collaboration with the construction industry, with the design community, to try and maximize concrete's potential to reach net zero. So research and development's a big one, to support manufacturing improvements in the way that materials and infrastructure are procured and used by all levels of government and the private sector. Obviously, testing and deploying technologies to help solve some of the technological challenges that are faced not only by the cement and concrete industry, like this is equally true for steel or for chemicals, you know, transitioning these large energy intensive plants to lower emission energy sources, you know, hydrogen, biogenic fuels, etc. Next. Code standards and specifications, so important. Building practices are evolving and will continue to evolve to you know, consider the impacts of climate change, but also can be used to drive, you know, made in Canada innovations for low carbon materials and approaches. You know, one of the things that our industry is really interested in advocating for is something called performance-based standards, or, you know, where you say like, okay, I need concrete in this application. I'm pouring at this time of year. I need to meet X, Y, and Z requirements. Like, what's the lowest carbon you can get me? Because there are so many factors that go into what you can do. You know, you can get a really, really low carbon sidewalk. If you're pouring it in the, you know, maybe I'm pouring a sidewalk in the summer. Yeah, you could get really low carbon there. I'm building a bridge in wintertime. Your options might be different. And then of course, right, you know, things like minimum cement content or limiting the use of SCMs are two examples that often prevent carbon reduction. I remember one of our engineers telling me that they got a request from a proponent that said, okay, we would like 30% emissions reduction on this project, but you're only allowed to use 10% SCMs. That gets pretty challenging. Next slide. Procurement, right? Procurement is a huge one for our industry, and actually for any of the building materials, right? Government policy that sets benchmarks and encourages market dissemination of lower carbon products are definitely a way that public policy can be used to help drive change. Next slide.
Sarah, yes, we're approaching our 10 o'clock time frame at this point.
I just had one more slide.
Okay.
And finally, just on quality data and carbon accounting. And so, you know, our industry has fully embraced regionally specific industry-wide average EPDs, environmental product declarations for both cement and concrete, as a way of quantifying and confirming our improvements on carbon reductions. And so many of our facilities and individual concrete mixes also have EPDs. Obviously, there is still significant work to do around the comparability of carbon data, and particularly as we relate to other products, but we are definitely committed to doing it. And so with that, I will conclude.
Fantastic. Obviously, there's a wealth of information. We did have some questions we wanted to carry on with, but we've addressed many of them in the presentation. And so we're going to have to ask individuals to hold off questions, send them to us, please, by email. And also, please let us know what information you feel is most useful to you. So as we continue with this series, so that we can keep the collaboration going, keep the information being exchanged between the parties. We saw here from the regulations and policies, the design industry, and what the actual steel and concrete industry, cement industry are doing, that we are moving forward. It's just a very big hill that we're climbing. So we're looking forward to moving towards the net zero together. Please become a green ambassador. Companies out there, let us know who you are and what you're doing. We're always welcome new individuals to our environmental committee, and let us know what's happening. The seminar also will be shared on the TCA YouTube channel. Thank you, panelists. The information was fantastic. Your knowledge is beyond, and we greatly appreciate your time today.